Remember. All right, y'all. So before we can take a second derivative of something, we need to take the first derivative of it. So would you guys mind taking the first derivative of just this one on the left? The 2x cubed minus 3y squared will equal 8. He doesn't want to talk to you.
There is mud.
He just kicked you out.
I know he did.
It's because I'm so loud.
I should make a face. I need to make a face.
The d squared y or dy squared dx? The dx.
D squared
X squared x.
x dy. I asked her last time. She was like,
dx squared?
D squared x dy squared.
But the dx is still on the bottom.
Oh. It's like this. Ignore what I just said.
Okay, which part am I ignoring?
Like this. The square. Oh gosh, I don't know.
Okay.
D squared y over dx squared.
How'd I do on the first step?
Yes.
Yes. Okay, and then do okay? Because the 6's cancel, yeah? Are we feeling comfortable about this so far?
Yeah.
All right, so next, what do you think we should do? Take the derivative of the derivative. That's what the second derivative is, yeah? So,
Yeah.
and what is the derivative of the right-hand side?
6y to the negative second dy dx.
Well, I canceled my 6's out.
Oh, I should have done that.
Okay, so if we did that, it's what? Low, D, high, I hate it so much.
This one.
Minus x squared times dy dx, right? All over y squared?
You could just do the product rule, right? If you did y and negative 1.
Product and chain rule, yeah. Yeah, you absolutely could.
Chain rule.
The dy dx, yeah. It would be negative 1 y to the negative 2 times dy dx, yeah.
Wait a minute. Hold on.
Why?
I just more of a quotient on that one. Wait, chain rule on dy dx.
So this,
y dx.
you would do x squared y to the negative 1, yeah? So that would become 2x y to the negative 1 plus negative y to the negative 2 dy dx all over, or times x squared.
Where's all the... Wait.
If you did the product rule, that's what you would need.
I'm just confused as to what the chain rule is.
The dy dx.
Y. Like you're taking the derivative of y to the negative first is negative y to the negative second times the derivative of y, which is dy dx.
Yeah, but how's that chain rule?
Because
Isn't
you're...
that just what you do?
So we don't have to simplify.
Well, in that case, when you call everything chain rule, then
I am not comfortable with this answer, if that's what you mean.
Okay, that's fine.
does that put everything chain rule?
How?
Because x squared would be chain rule then.
'Cause you guys-
dx over dx is 1.
Yeah, but that's still chain rule, is it not?
Yeah.
So, the why are we specifying that's chain rule here?
Because that's the one.
Because, and your specific thing was quotient rule. And let's say that wasn't a y. Let's say it was a 3y squared plus 5. Then you would have to multiply by 6y dy dx. Like, you would still have to take the derivative of the inside of whatever got raised to the negative 1 power. Like, when you do this, you have to use both the product rule and the chain rule for whatever this is. And sometimes it's a function like y. Sometimes it's a function like a more complex function in which you would have to use the chain rule. All right, why am I not okay with this answer the way it is?
Which one? DX is.
This one. Yeah, this needs to be in terms of x and y. And it's the second derivative currently is not in terms of x and y. Is everybody with me? Okay. So, what do I do?
Plug in x squared over y with dy dx.
We know, so I'm going to rewrite that part as 2xy minus x squared. We know what dy dx is.
Isn't it 2x? It's 2x over y. Right.
Hmm?
Never mind. Alright, never mind.
And then, personally, I would write this as 2x over y. Like, I would simplify it like this. I would simplify those terms and then simplify these terms. Because I think this is much easier to look at. But to each their own.
You'll accept the big fraction.
Mm. Mm.
Yeah, it was,
Yeah, that was. Oh, was that Are you trying to say that that was a little bit like ambiguous? Yeah, I wonder if that was on purpose. Yeah.
I'm guessing it was, but I feel like we appreciate a more direct answer.
What if I don't have a more direct answer?
Then we can say that. It's preferred, but you're not gonna take away points for us not simplifying.
That's what I heard.
It-
That's what I heard.
I heard that too.
So I heard we don't have to simplify and we
But
can
it
just
might
leave
be
it.
more convenient at times to simplify. Just like there's a disconnect right there.
There's no disconnect. No, there's like intentional pain in the butt. That's me right now. Yeah.
Yeah.
I'm intentionally not answering. It's not a disconnect in that I don't know what you're asking. I'm just not answering it. Yeah. You're welcome. You're welcome. Yeah. Yeah.
So we have to figure it out on the test.
Let's put it this way. On the quiz that you guys just took that I passed back yesterday. Yeah. Some of you didn't simplify stuff all the way. And if the simplifying process got in the way, if you got to the right answer, I gave you credit for it for the most part. Okay. The what you are going to do with it will determine how much I care about it.
So I just simplified just in case.
If I'm asking you, for instance, to find the concavity at a specific point, which we're not doing this unit, but we will do in the next unit. We'll do all the curve sketching stuff. Then I would expect it simplified so that you can find that concavity relatively easily. In this particular case, since we're not going anywhere further with our answer. Yes.
Why is for the dy dx, why is it x squared over y and not x squared over negative y?
Because when I subtract the 6x squared over, it would be negative.
Subtract.
So like if I'm solving for dy dx, I'm going to subtract 6x squared from both sides first.
-6 over -6.
So then I'd have negative 6y dy dx equals negative 6x squared. And I would divide by negative 6y. Hmm? You're welcome. Do you want to look at the next one? Should we look at it together?
Sure.
Sure?
Do it.
Let's see. Cosine of x plus 2xy plus x squared times dy dx equals 0. Did I get that right? So what does that make dy dx?
-2
Huh. Cool. What's wrong with this?
That's only,
That's only the
you have to
first.
take this.
Oh, okay. I think these are so fun. I feel like they've got a puzzly vibe to me.
I'm glad you like them.
Does it matter if it's negative 2xy minus cosine of x or negative cosine of x minus 2xy?
Okay.
X squared times negative 2y minus 2x dy dx cosine x.
Let's see. So that would be x squared times negative 2x. So the derivative of the top, we would have to use the product rule here, yeah? Because this is a product. Okay? So it'd be negative 2x times dy dx plus negative 2y minus, so that's the derivative of that piece. And then the derivative of cosine is negative sine, so this becomes a plus sine of x. Okay? Minus. So that was low d high. So now I'm going to do 2x times negative 2xy minus cosine x all over x to the 4th. Easy peasy, lemon squeezy.
But now do we have to put in the...
Oh, I don't know. Yeah. So what do you guys want to do next?
Should you distribute the 2x and x squared before you plug in dy dx or after?
Oh, why aren't you guys mad at my notation here?
It wasn't a square.
Surely, yeah.
So like what do
How
we
is it
do?
going?
Oh, I don't know. There's so many things we could do. And so the should we do this or what do we do? Like those, you do what you want to do, but it just has to make sense mathematically. I look at this and I kind of want to say, split this up to here. Like, because, like, if I do that, what happens to this x squared?
Because
It cancels and I have an x squared on the bottom. So I don't have that nasty distributive property problem.
makes sense.
And I can replace my dy dx. And really, I can separate any of the plus and minus signs, yeah? On the top. So I might then, I'm going to kind of decrease what I circled here. What if I looked at it as just here? Okay? And then I'm going to do, you know, these pieces, because those can't be simplified at all. Do you guys get what I'm saying here? So all of a sudden I will have plus negative 2y plus sine x over x to the 4th. Can't do anything there. And then if I look at, say, these ones, I think that looks like a pretty lovely simplification of it. There's probably one more thing I would do.
Nifty.
Huh?
It's pretty nifty. How you did that? I like it.
There's probably one more thing I would do. There's one thing that's bothering me about this. Well, I could probably cancel that out and make this negative 4xy positive 4xy minus 2 cosine x over x to the third.
Would it be plus 2 cosine? I'm right there with you.
Are you?
Couldn't have said it better myself.
I don't believe you. I think you're mocking me right now.
Wait, but if it's x cubed, and we combine both of them?
Well, let's see. What do we have over here? We also have another 4xy plus 2 cosine x. Oh. So yeah, now we have even more like terms that we can simplify even further. Yeah.
I have no room.
Huh?
So I have no room.
Isn't this fun?
Not at all. I'm
So
lost.
It's really Randall.
I'm glad you
Like, I'm
enjoy
like, fucking stuff just being like.
I really do. This is like a lovely little puzzle for me.
happy for you.
Oh, you're so good.
What?
Oh, wait, it's the exact same product once you multiply out on the top.
Where is there a 2xy? Oh, because that,
Because I plugged this in
yeah.
for dy dx. Man. Guys, I could do this all day.
You know, you're not the first.
Not only that, like, as math people go, I'm one of the nerdier ones. What a fun question this has been. Don't you guys wish we could do these all day? Is that just me? Is that just me?
So are we
Taking a
allowed
long
to
time.
like do that for any problem that involves like something with the frequencies, like for the purple part?
So you can always, for the purple part.
That purple part.
I got two. I got one right there and one right here.
Taking this one,
Okay.
okay? And that's only if the terms are being like added or subtracted, right?
And
You can break
you can do it with the numerator. You cannot do that with the denominator.
Okay.
Right.
Okay.
My question is,
Did we go from the the multiple color row to just the blue row, or did you just rewrite the blue row?
Well, it's all just rewriting.
It's true. Think about it.
So okay, this orange became this, and then I rewrote it in blue because it's like terms with this one now. So this plus this gave me this one, and then this just came along for the right. Good.
oh, I was gonna ask, because the x squared was distributed to like all the terms on the top, how are we able to separate it again?
I didn't. That's why this one was only over x squared. I canceled it before I distributed it.
Okay.
So
Wait, how
so
do we
you're
get-
allowed to bring it to just like one part of the equation, but not like.
You can separate out a fraction by plus and minus signs. So if I gave you
Why is there an X?
If I give you x squared plus 3x plus 2 over 1. No, anything else. 17. Okay. I'm allowed to call that x squared over 17 plus 3x over 17 plus 2 over 17. I can split that up, right? That's all I did.
What if there's like, what if that's in parentheses and there's like a 2 in front of it though?
Yeah, because isn't that what
Yeah,
you're
yeah,
doing there?
exactly.
Like, because if you're
That's
multiplying
what I'm
that, so you're
confused
canceling
about.
out the 2 for only one of the products, but then the x to the 4th doesn't matter, the x to the 2nd?
Yeah, it's like,
In the purple? Shouldn't it?
Oh, I see what you're saying.
yeah, like.
Yeah.
Applied it to one of the
So
products.
yeah, that's why when I said, oh, I can just separate it this way, I was wrong. So it'd be like this.
Oh.
You cancel out the x on the bottom, and then x squared on the bottom, and the purple one.
Oh, French.
Oh my gosh, hold on, I have to rewrite this.
I think we should all.
Oh, actually, yeah, that would just turn this into an x squared. Yeah. Yeah.
What's the second piece?
All right. So since this x squared, since these two pieces were also in the parenthesis, there would be an x squared out in front of these ones too, which would turn this bottom exponent into an x squared. So easy.
I just don't want to do it.
I understand. We all have things we don't necessarily want to do that we do. Yeah.
So
And
in
your
the end, we still don't have to
was,
distribute
is
it.
the way you did it
No,
much
it just
faster
cancels
than
out that
like fully
product, too.
distributing out?
I have no
Just the
idea.
bottom one x squared.
I have no idea. Like, I try to look at it like everybody has different things they hate. I cannot stand fractions within fractions, so I want to try to simplify those down.
To get them out. I see, because then it wouldn't have.
Sure. Maddie, you came at a really great time, like right when this problem is done. Yeah,
Yes, right.
because everybody's pretty annoyed with it. Yeah. You guys, it's about to get either better or worse depending on your own perspective.
So, if you think it's
Right.
gonna be better, it's gonna be better. If you think it's gonna be worse.
I think it is reasonable to assume that if I'm asking you a question about a second derivative, I might not make it as complex as the ones in the notes.
I don't know.
It's so
What is
tiny.
it? Blaming, defending. Blaming, defending.
Yeah, I don't know if I can't see that
B,
part.
C, D, G.
I don't know if I got the right answer. Squared? How's it squared?
Because the x squared in the parentheses was applied to everything in the
That's what
parentheses,
we
so you had to cancel it out.
Well, before we yell at somebody for asking a question that you just asked, I happen to have taught all of you before, and I'm certain you have done that as well. So let's just breathe. Yeah.
Yeah,
There,
I have
but it
that.
also had to be applied to the other part
Let's
of
get after it.
the
Let's get after it, yo.
like right here over x four. It had to be applied to
Let's do it,
the
guys.
so then you just canceled it out.
Why was X
Because it's the x squared is applied to the whole parentheses. So when we're
We already
isolating
divided
it,
the front.
I know, but we're like saying that it's an x squared times this and x squared times.
I did not understand that at all.
Okay, well, ask my sister, maybe she can explain it.
Yeah, I was originally asking my sister to be fair.
Same thought.
Next page.
I think we should work on implicit exponential functions.
Great idea.
Next page.
Thoughts?
The new rule we used.
The new rule we used?
The a to b u times u prime times ln.
Oh, that works. That works really well when the base is not a function.
we change,
The base was a constant when we did that.
can we change the x, or can we change the x to the sine x to an e to the ln of x to the sine x?
Because you did differentiate. Translate.
Like that?
Yeah, and then put the sine x out in front of the ln. And then
I like it.
just take the derivative
He's on
with like product rule and or chain rule.
It's going places. Plan the line. Hold it. Plan lines.
So how would I keep going with this? I'm not against what you're saying.
Okay. And then, so
That was not how I intended to show you guys how to do this, but I don't have a problem with what you're saying. So keep going.
so then it's e to the sine x l times ln x, and then times cosine of x times ln x plus sine of x over x, like all in parentheses. Then I would simplify the e to the sine x ln x back to x to the sine x.
Didn't you like learn calculus before you took AP Calc?
Not really.
I feel like that just added more.
Okay, I'm going to show you guys the approach that I would have taken. And let's see how close they are. I think this is fine. There's nothing that's jumping out at me that I have a problem with. How would you guys feel if I took instead? If I took the natural log of both sides first, would that be comfortable? So all of a sudden I would have the natural log of y is equal to sine x times the natural log of x.
Can you just do a quick run through of the natural log thing again?
What about it?
Like how you move the sign down?
Like, it doesn't, it's not just for a natural log. It's a log to a power, okay? You can always bring the exponent down in front of a logarithm.
Okay.
It's just a log property. Now, it stems from, the answer to a logarithm is just an exponent, right? So if I take x squared to the third power, I would multiply my two exponents and call this x to the sixth, yeah?
Yeah.
Okay. Now, the answer to a log is equivalent to just the 2. It is an exponent. That's what a log is it's an exponent on an expression. So a log to a power is an exponent to an exponent. So you can just multiply those two things instead. Okay. Now, if I did this, and now I asked you guys to take the derivative, what would you say?
1 over y dy dx.
1 over y dy dx
And then what was in the parentheses?
equals cosine of x times the natural log of x plus sine x over x. So what would I need to do to find dy dx?
Multiply by y, which you're given is x sine of x. They mean the same thing.
Oh, yeah.
Same exact answer.
Are we finding a second derivative as well?
Nope. No. I think you guys would kill me if I did that. Though the second derivative for this one wouldn't be, well, it would still be bad. I still wouldn't like it. Yeah. So I am very comfortable with you taking either of those two approaches. Yeah.
In like your final answer, could you just keep it as y
No.
times? Oh no, it has to.
Okay, so when the initial function is given to you explicitly like this, I would expect the derivative to be the explicit form of the derivative.
Okay.
So, William had his way of doing it, which I think is lovely. If it makes more sense to you to bring that y down, that sine x down by taking the natural log, do that. Either way, you get the same answer. Everybody okay? All right, can I give you one to try? Oh, yeah.
Is that the fourth root or is
It's I believe that is to the fourth power. Yeah. Because? Did you get something similar to this or no?
On the left, but not on the right.
Actually,
Shouldn't it be?
I got the first half, but the second half is wonky.
Why is there no x to the third minus 1 over 4 on the top of your fraction over there?
Of this fraction? Because this was me multiplying by y. I would do times y times y.
How did you get the 3 over 2 in the second?
Yeah. That the exact same
Is
thing
I
on
have
the
the
left.
exact same, yeah, like on
Did
the
you
left,
just
and
do
then
big plus
my
big?
denominator is the same, yeah.
I have,
And then my top was x3 minus 1 to the 4th. Was that yours?
Yeah, that was mine.
I have 3x cubed minus 1 to the 4th on the top.
Where'd you get the 3
From the 3.
From the chain rule 3.
Oh, shoot.
But how do you get rid of the x to the third minus 1 on the top?
Where?
That comes from the gift part.
Oh, yeah. I didn't do fig plus gif, so I don't know.
Okay.
I used logs to do it instead because
I got the exact same thing except for that.
All of us.
No, but like a different thing's wrong with mine.
No, we have the exact same thing.
I just have an extra x times x
Alright.
cubed minus.
So if I'm doing product rule here, okay. dy dx would equal 4x cubed minus 1 to the third times the square root of 3x minus 1 times 3x squared. Yeah? Plus x cubed minus 1 to the 4th.
Don't you need to multiply by this second? Isn't it big plus gif, so it's not just increase?
No.
it's just writing plus.
Here's the gif.
Instead of g prime f.
Okay, the underlined pieces are the derivative of the first function, yeah?
Yeah.
All right. And then times, and then we'd have 1/2 3x minus 1 to the negative 1/2 times 3 by the chain rule.
Oh, because you're doing
Chain
the
rule.
1/2 instead of doing the square. Okay, I see.
But that's still.
I just already brought it to the square root thing.
There's a 3x squared on the left.
So the one where I take the derivative of the x cubed minus 1 has the 3x squared. The one where I take the derivative of the square root of 3x minus 1 is just a 3.
Yeah. Yeah.
Like each piece you're only applying to the chain rule to the piece that you're taking that derivative of.
Yeah, she did that right before the plus sign. Oh, right after the plus sign. But that's still, so if we simplify, yeah.
Would you be able to zoom in on
Yeah.
your font heights with it, right?
Increments would be different though.
Oh, I just never included this piece when I multiplied this fraction.
Okay.
Okay,
That's
that's
the one
all
thing
the
we
issue.
had that.
Okay, so we're all tracking.
Yeah, that was the same answer.
There we go.
So, just like the other day, I sometimes think that using logarithms to take derivatives can make things easier. Like when I gave you the Alright.
Next one.
So go ahead and give this one a shot.
Where are you getting the 2x on top?
Chain rule of 1 over x squared plus 1.
Can I leave it undistributed?
Again, I think this is faster / quicker than using the quotient rule in this particular problem.
Did you say you could leave it in that?
I didn't say anything, yeah. I think there is value in you guys recognizing when it's appropriate to simplify something and when it's not. If you're not using anything with it, does it really matter if you simplify it or not? But be ready for, and not that long, you getting questions where you're going to have to simplify it. And if you want to get the practice in simplifying it, it's not the worst thing in the world.
This semester, how did you, like, for the first part of the equation, like the one right next to the dy dx,
Mm-hmm.
does the bottom just like cancel out?
Well, remember, I'm distributing this x minus 2, the quantity squared. So I'll have 2 of them on top and 1 on the bottom. Because I'm multiplying this whole side by y, yeah?
Oh, so they just cancel. I got you, okay.
Why does x minus 2 times the square root of x squared plus 4
Hmm?
equal the square root of x squared plus 4? Oh, because it's, never mind, I see what it is.
Let's do one more, then we'll take a break before we talk about inverse functions.
explain why it's to the 3 halves?
Because this is to the first power, and if you wanted to, you could think of this as to the
Or the 1/2?
to the 1/2.
Okay, so, okay.
So we just add those exponents. All right, we're definitely at a stage to take 5 once you're good with this question. So I'm going to leave it up. Why don't we come back at 23?